Welcome back to The Explainer. So today, we're tackling a pretty massive challenge in modern tech. We're looking at AI reasoning condition monitors and how they pair up with integrated process excellence. Let's get right into it. How do we actually know when an AI loses touch with reality? I know, it sounds a bit like sci-fi, but honestly, it's a very real operational blind spot right now. You see, AI systems are making incredibly complex decisions out there, routing global supply chains, managing really sensitive healthcare data, or even running entire manufacturing floors. But the thing is, AI doesn't inherently understand the physical reality of a factory or a hospital ward. Imagine an AI just hallucinating and suddenly ordering 10,000 pallets of the wrong pharmaceutical just because of some subtle logic glitch. We desperately need to know when an AI starts drifting or, circling an echo chamber of its own past conclusions. Basically, we need an alarm system. Okay, let's dive into this. A whole new category of instrument has recently emerged to act as that exact alarm system, and it's called the Reasoning Condition Monitor, or RCM. And its brilliance? Well, it lies entirely in its narrow focus. As this quote perfectly captures, it observes the condition under which reasoning is occurring, not whether the reasoning is correct. Think about that for a second. Even the absolute best monitors out there right now aren't designed to be arbiters of absolute truth. They have a completely different job. To put that into perspective, think of an RCM as the check engine light on your car's dashboard, but, for human AI reasoning. Its job is just to make sure the AI remains oriented, correctable, and reachable by external evidence. When that check engine light flashes on your dashboard, it doesn't tell you, hey, cylinder 4 is misfiring, or you need exactly 2 quarts of synthetic oil, right? It simply, yet urgently, warns you that conditions under the hood are deteriorating, and you need to pull over and take a look. So, looking at the contrast here, you can see a very clear boundary. On one side, we see what an RCM is truly brilliant at. It watches for orientation drift, it tracks signal independence, which basically ensures the AI isn't just listening to 5 different echoes of the exact same bad data, and it flags lost corrections. It is absolutely phenomenal at warning us when something is wrong. But look at the limitations on the other side. By design, it can't tell us what the right answer is. It can't arbitrate truth or provide specific domain context, because, no single instrument built to monitor AI can possibly contain the ground truth for every single business on Earth. And that brings us to the missing link: supplying domain-specific ground truth. Because an RCM's blinking check engine light has absolutely nowhere to land without a domain-specific blueprint to fill the gap. I mean, if the monitor flags that a correction was lost, how do we know what the correction should have been? Or if it flags a missing external reference, what exactly is the reference it should be looking for? We need a layer that supplies the actual, hard, domain-specific ground truth. And this brilliantly illustrates where integrated process excellence, or IPE, comes in. This is a framework created by John Cachette, and it translates those abstract business goals into structured, measurable reality. Rather than just being some static list of rules, it's a self-reinforcing cycle. You go from creating a positive environment to identifying key variables, then developing and communicating process worksheets, and ultimately controlling and improving the process. So when an AI is reasoning about a business process, IPE acts as the definitive rulebook that the AI and the monitor watching it can constantly reference. Now, underneath all those steps sits the real engine, the IPE causal architecture. This structures key input, process, and output variables, often referred to as KIV, KPV, and KOV, explicitly stating what drives what. Remember how the RCM is your check engine light? Well, this causal architecture is the mechanic's diagnostic manual. It forces an AI's kind of vague claims to be actively checked against a defined physical reality rather than just blindly asserted. It literally maps out the exact mechanics of your business. So let's map out how these two systems actually interact. When the RCM throws a warning about a lack of external reference, meaning the AI is basically reasoning in a vacuum, IPE provides concrete telemetry from your resource planning software or physical Gemba walks. And that just means actual human observation out on the factory floor. And if the monitor flags signal independence, well, IPE solves that by requiring strict evidentiary labels, proving whether a relationship is genuinely established or if it's merely assumed. Let's move to the next set and see how this builds, because the solutions get even more granular here. If an RCM warns of a correction retention failure, which means an old error somehow slipped back into the AI's logic, IPE stops it cold by enforcing distinct approval and validation dates. A correction simply isn't retained until live data proves it.
And what about when management and frontline operators disagree? Well, IPE steps in with disagreement preservation. It keeps artifact records open based on hard evidence rather than just, defaulting to the boss's opinion.
Finally, the RCM watches for operator compensation. This is when human workers are secretly doing manual workarounds to prop up a failing AI just to make it look good. And come on, we've all seen that happen. IPE catches this through an observed variance log, perfectly quantifying that manual human effort. It also measures correction margin by calculating the ratio of assumed relationships versus firmly proven ones. And as you guess, more assumptions mean a dangerously thin margin for error.
So, when the alarms do ring, what's the actual protocol? IPE translates those escalating RCM alarms into highly specific, rapid interventions. First, reacquire. That means stop trusting the AI and return to live telemetry and observation. Then, rebind, which means tearing down the AI's definitions and reconstructing them using only strictly established relationships. And lastly, escalate. This takes the issue entirely out of the AI's hands and routes it directly to the human owner-operator disagreement process. It is rapid, and it's absolutely evidence-based.
Now, the good news is you don't actually have to build this ground truth from scratch. Organizations can utilize IP packs. These are sector-specific implementations pre-built for industries like healthcare, manufacturing, steel, pharma, and plastics. By applying those specific regulatory contexts right out of the gate, you get to deploy a proven framework as a starting point rather than staring at a terrifyingly blank whiteboard.
To summarize our core thesis here, these are really two halves of the exact same problem. They do not replace each other, they form a complete reasoning framework. The reasoning condition monitor provides the essential discipline of flagging when an AI needs inspection, but IPE supplies the vital ground truth for that inspection to actually land on. Without the monitor, you're flying blind, but without IPE, you know you're crashing, but you have literally no idea where the ground is.
Which leaves us with this final, rather critical thought. If AI is reasoning about your business today, what exactly is defining its ground truth? Is it concrete evidence? Or is it just a towering stack of assumptions? If you don't know the answer to that, well, it's probably time to build that foundation. To explore this domain instrumentation layer for your own AI deployments, you can reach out to John Cowchat at IPE Services. Thanks for joining me on this explainer, and keep asking those tough questions.